Okay. Now, today's lesson is we need to do 7.2 B, okay, which is a washer method. All right, so now let's look at the second part of 7.2. Okay, so we do disk method. So this washer method is also a disk method in a way, because you're finding a volume of a big disk and subtract what? Small disk. Okay, so look at this washer method. Okay, objective, find the volume of a solid of a revolution using the washer method. The disk method can be extended to cover solid of a revolution with a hose by replacing the representative disk with a representative washer. Okay, the washer is formed by revolving rectangle about an axis, either x-axis, y-axis, y equal to 3, x equal to 4, whatever, okay? So if R and R, the small r and bigger R are the inner and outer radii of a washer, respectively, and W is what? Width of a washer, and then the volume is a washer is like this: pi times what? Big radius square minus what? Small radius square. So you can visualize this. You have disk, the bigger disk, which is R. Okay, now I want to subtract the what? Small disk. The blue disk is a larger radius, okay? And then you have a what? Smaller disk, the purple one. You subtract those. Then what do you get? If you took away this in the middle of them, what happened there? You get a hole in the middle, right? So you're gonna have a hole in the middle. So it's gonna be looks like this. You're gonna have a washer. Now, so if you rotate this around the x-axis, so we're picturing this like here. You see it? Okay, in the middle you have a what? Nothing in it, it's hole in it, okay? It's like a funnel, right? Funnel has an inside empty, right? That's what we're gonna have. So this is how you find. You wanna find, let me make it bigger. So you do what? Outer area, outer times this up here, but this is how you do this, all right? Minus what? Area inner this times what? This of this, you subtract those. Okay, but look at this one. The width of this and width of this, they're same thing, right? Can I factor them out? So that's what we have. Outer this minus inner this, but the width is the same. So you want to write down as a mathematical formula, what do you have? Big R squared minus what? Small r squared. All right, in this case, the problem that we have, oh, am I already doing an example problem? Okay, so example problem, let's do example problem. But does everybody understand the concept, how to use a washer?
So it's like this method, but then we do another this method.
Right. Exactly right. So we're doing a 2-disk method, right? Big disk method minus what? Small disk method. That's what it is. That's a washer. That's exactly right. So I'm going to give you an example. So I have a 2 problem. I have an equation. So I'm going to give you equations. So I have a 2 problem. Big radius is the square root of x, and the small radius is what? X squared. So I have this 2. All right, now what is the width of this? Since I'm going to write down in terms of x, so what is my x? What is my width?
Yeah.
Dx. Are you following me, class? Okay, it's a dx. Now, I'm only interested in single washer. So how do you find the single washer? You're going to find the what? Area of outer disk minus what? Area of inner disk. So outer disk is which one? Square root of x. And what do you do? Square that. Inner is what? X squared. Square that. So what do you have then? X minus what? X to 4. So that is one washer. Can everybody see where this minus came from? Right? So it's bigger one minus one, small one. That's why you have a minus. Now, the looking at this problem. Then what do you do? You're going to take antiderivative of that. What do you get then? X become what? X squared and then divided by 2. X to the 4 become what? X to the 5 divided by what? 5. And you are evaluating between what? 0 to 1. And you plug it in. The first one you put 1s, the other one you what? Zeros. Then you get this. And you simplify this, you get 3 over 10 pi. Is everybody with me? All right. So, say again? It's a pi r squared. Circle, that's right. Right. So remember your formula is always this, pi r squared and then what? And the width. So this is the one that you keep doing it. Okay. So when you do numerically, you have this, and I'm not gonna go over because I want you to look over this by yourself. Okay, because it's exactly the same way we do. As you see, I do exactly the same way. Nothing changes much. Okay, look into that. And then let me look at the second one. This is a very, very good problem. And you will see a problem like that in your homework problem too. Okay, now, this time, this particular problem is utilizing regular disk method and the washer method. Are you with me, class? Look at this. Look at the picture. Oh, does everybody see it? This top part, you have a missing part. There's a hole in it. Look at the bottom part. It's complete solid. Does everybody see it? The bottom part between 0 to 1 is just solid. There's nothing to take out. So you're gonna just have simply what? Regular disk method. From 0 to 1, you do what? Regular disk method. What about 1 to 2? Washer, because you're gonna do a big disk minus what? Small disk. Are you following?
0 to 1 disk.
From 0 to 1, just regular disk. What is your radius? What's your radius?
My radius is 1.
1 minus 0, which is what? 1. We got this one. This is the easy part. That's completely done easily. In fact, the answer is what? Just a pi. Okay, just a pi. Now look at the top part. What's your big radius? What is this radius?
0 to
1. 1 minus 0, right? 1 minus 0. The big radius is 1. What's a small radius? This equation, right? What is this equation called?
Square root of y
minus 1. The small radius is what? Square root of y minus 1. Are you following me, class?
in terms of y because it's like horizontal.
So this picture right here, you can rewrite it as what? Big disk, which is 1. The radius is 1. What's your smaller disk? That'll be square root of what? Y minus 1. Do you see that, class? Okay. Then if you know that, then we can do this problem. So this problem you have to divide into 2 sections. I just told you, right? Divide into 2 sections. And the first one, the section 1. I'm gonna call it this top to be section 1. This is the section 1. This is a section 2. Okay, so let me do section 1 first. Section 1, what do? You're gonna find your radii. We'll talk about that, the big radius, the larger disk, and smaller disk is what? Square root of y minus 1. Why is that so? Remember, y is equal to this. So solve for x, what do? Y minus 1 equal to x squared. So x is what? Square root of y minus 1. I'm not interested in negative number because this is a real distance. So I'm only going to carry one positive part. All right, so now what do? Of course, it's a dy, right? So dy, the width is dy. What else? Width is dy, and then what? Volume. How would you find? Area of a what? Larger one minus what? Area of a smaller one. So larger one is what? 1 square. What's the smaller one? Square root of y minus 1. So 1 square is simply 1. Square root of y minus 1 to the square what? Square and square root cancel out. You have what? Simply has y minus 1. You simplify this one again, you get what? Negative y plus 2. So that's your single washer. All right, but I'm not interested in single washer. I want what? Entire washer, okay, addable together. So I'm gonna take antiderivative between what? 1 to 2. Did everybody see where this 1 and 2 come from? Right? Remember your picture? Is what? 1 to 2. Right? Everybody with me? Okay. And now we're going to take an antiderivative over there. So negative y become a what? Negative y squared over 2. Do you understand? Take an antiderivative there. Plug it in 2. Each time you see it. The next is what? You plug in what? 1. You simplify that, you get this. Pi over 2. All right, so first section is done. The second section is the easy part. Second section is simply what? One big disk, right? So what is your disk radius? 1. And then you plug it in your formula. And just like do, then you get what? Just a pi. So what is your total volume? You adding both of them, right? Volume from 1, section 1, and section 2, you add up together, you get 3 pi over 2. That's what we have. So that is 7.2. Now, let's look at this one numerically. So numerically, when you do, what do you do? Just like you do before, okay? Just like you do before, what do you do? Define your function. So y of h of y equal to what? 1. That's a big one. And then what is the other one? K, smaller radius. Are you with me, class? Okay, so if I'm looking for one washer, what do? You gotta choose your width. In this case, I chose 0.001. And I'm gonna do between 1 to 2. So I'm doing on the section 1, top part. All right, so you're gonna do what? Washer 2. H squared minus what? K squared. And you just multiply that. That give you what? 1 washer. So how many washers did I just make it? By doing a width to be 0.001. You got 1,000 of them. Okay, 1,001 washers, you just made it. What is it, Perry?
I was talking about the range notation. I didn't understand what it was.
This is how much you increment. Right, that's right. The middle one. So I don't want to keep changing this one individually. So I define width to be this. So whenever I want to change my increment, then what do? You come over here and you change that increment. So I can change into an even bigger one. In this case, you have what? 10,000 washers. All right. So you run that and you get sum to be 1.57. So upper region, the upper part, the washer part, the area, the volume is 1.57. So I'm going to the second part. Second part is what? Simply just 1, right? There's no subtraction, just that. So when you also do that, and this total volume is 3.1. So you look at the section, the second section, area is 3.14, which we know, right? Pi is 3.147, right? So when you add it together, you get this. And true solution is this. So it is pretty good. Look at the error. It's less than 5%, right? It's 0.001, so it's less than 1%, which is very good. You only had a 1,000 disc. 1,000 disc and 1,000 washer, but really good answers.